So good morning and welcome to lecture number 15. This will be the last lecture in this series, and today I will be covering interrupts and exceptions. So let us spend some time on understanding what we mean by an exception. Exception is defined as something the program is not intended to do, or a scenario that is not normally expected when a program or a process is in, when a program is in execution, but it has happened. These abnormal situations can actually happen either when a program itself does something wrong. For example, there is a divide by 0. When there is a divide by 0, the system doesn't understand what next to do, because divide by 0, if I do a division with the denominator as 0, the operation is not defined. Another example that we saw from the previous classes is that I overshoot a segment. I call it as a segmentation violation. When I had fixed some size of the segment, the operating system has given some size of the segment, and you overshoot this, your program tries to access outside this segment. The third could be a page fault. We saw about paging in the last class, and we also defined what page fault is. The page fault basically means that a page the program needs is not available in the main memory, and so this means that the page which is in the secondary memory has to be brought into the main memory. So these are all examples of scenarios which are caused because something is wrong with the program. I have a program that is running, and the program creates these problems. It is wrong in the sense that it had a division operation in which the denominator is 0, or it tries to access a segment beyond its limits, or it is trying to access a page which is actually not loaded in the memory. So all these are caused because of the action taken by the program. So these are called as traps. Traps are exceptional scenarios that are basically caused because of some are exceptional scenarios that are caused because of an issue in the program. Other type of exception is that when a program is running, suppose you press Ctrl C. So this is an external input which you give through the keyboard. This has nothing to do with the program. This has nothing to do with any malfunctioning in the program. This is actually caused because you did a Ctrl C from an external input, namely keyboard. So this exception scenario is caused by some action which is not by the program, but which is something external to the program. These type of exceptions are called as interrupts. So exceptions or abnormal or not expected scenarios during the execution of a program can happen due to two things. One is due to a trap, another is due to an interrupt. What is a trap? I repeat, a trap is an exceptional scenario that is caused because of some malfunction or some undesired functionality in the program. Some examples of that are divide by zero, segmentation violation, and page fault. An interrupt is again an exceptional scenario which is caused by some action that is external to the program. For example, you press a Control C in your keyboard, which actually goes and terminates a program. Now, what happens when these scenarios, what exactly happens inside the CPU when these type of exceptional scenarios occur? What happens when there is an interrupt? What happens when there is a trap? This is what we will be covering in the next 20 minutes. So let us see, whenever there is, so exception is the common name given to both interrupt and trap. Whenever there is an exception, please note that exception transfers control from the program that is executing to the operating system. How does this control happen? And what should happen after this control is transferred? These are all the things. So, how does this transfer happen? What happens after the transfer? Okay, so these two we need to understand from the hardware perspective, right? So in the next 15 to 20 minutes, I will be covering what exactly happened, how does this transfer actually happen. The transfer is from the program that is currently executing to the operating system, and what next. So let us try and answer these two questions. So the question number one is, how does this transfer happen? Now, all the modern processors that you see, they basically have something called vectored interrupts. What do we understand by the term vectored interrupts? They are basically all the interrupts that you see, all the exceptions that you see can be numbered from 0 onwards. For example, if you take the Intel processor, you will see 0, what you call as exception 0 stands for divide by 0. Exception 1 stands for some debug, and so on. Exception 11 stands for some stack overflow. Exception 12. I may be slightly wrong in that, but this is how it is organized. The exception 13 can be some general protection fault. This includes your segmentation fault. Exception 12 can be a page fault. Like this it goes on, and it goes up to 255 different types of exceptions that could happen. So the hardware, if it is a trap, I hope you now know what a trap is. A trap is an exception that is caused by the program. Immediately the hardware detects what number is the trap. If it is divided by 0, it knows it is 0 interrupt number or exception number 0. We could call this as, to be a little more consistent, we will call it as vectored exceptions. When a trap comes, the hardware, the system, the CPU actually recognizes the exception number. Right? That is why these are all called as hardware exceptions. For example, if there is a divide by 0 when the program is executing, and when you go and into the ALU, when the denominator is 0 and it's a division operation, immediately the hardware will recognize that it is a divide by 0. Suppose there is a segment which is defined for 100 bytes and the program starts accessing the 101 byte, 101st byte, immediately the hardware will recognize that there is an exception. Similarly, when there is a page fault, for example, the hardware will recognize that there is a page fault. What it means by recognition? It will basically give you the number associated with this, say 0 or 11 or 12 or 13. Right? Now, beyond say 31 or 32, I am just talking with the Intel architecture in mind as a case study. Beyond some point, these entries, say 32 to 255, they are associated with software exceptions. What are these software exceptions? They are basically interrupts. Please understand this. When a device is added to the system, for example, a hard disk is added, a keyboard is added, a mouse is added, immediately for each of these devices, an interrupt number will be associated with it. So the mouse will be some, say for example, 70-second interrupt. So 72 would be the mouse. Say 78 will be keyboard. Some 150 will be some joystick. 175 may be some camera. So like that. So for all the devices that you are adding, external IO devices that you are adding, an interrupt number can be associated with this. How do you associate an interrupt number with a particular device? There is something called programmable interrupt controllers. Actually, now you have an advanced programmable interrupt controller, APIC. These are available in modern processors, including the Intel architecture, and you can use these advanced programmable interrupt controllers to basically assign a particular interrupt number to a particular device that is attached to the system. So at this point, for our understanding, when there is a trap, the architecture itself recognizes the trap, and what we mean by recognition, again I repeat, is that it will know the exception number. When there is an interrupt that is generated by an external peripheral device, again the hardware will know which device is creating the interrupt. Essentially it will know what is the number of this interrupt or number of this exception, and that is basically achieved with the help of this particular unit called advanced programmable interrupt controller, which will assign an interrupt number to every peripheral that is added to the system. So at the end of the story, the point that is clear to us is, when there is a trap or when there is an exception, immediately we will know what is the number of that. When there is a trap or when there is an interrupt, we immediately know what is the exception number. In this vector of 256 entries, we will know which entry is creating that exception, right? So the first point is, hardware recognizes the exception number. In both the cases, whether it's an interrupt or a trap. Okay. Now, when the operating system loads, it loads an interrupt, or I'll just change this, an exception descriptor table. Many books call it as interrupt descriptor table, but we should call it as an exception descriptor table. This table will have an entry for every exception. So in our case, say 0 to 255. And what will be inside this? Each entry will contain the address of the OS code that should be executed. When the corresponding exception happens. Okay. So when there is a divide by 0, the hardware will recognize that there is a 0 has happened, and immediately it will go into this table, the exception descriptor table, and find out what is the address of the operating system code. The operating system has a huge code. Some part of that code should now start executing. That means I should transfer control to the operating system, because to handle this particular exception. So in 0, I will have the address of the operating system code that should be executed when divide by 0 happens. Example, in say some 12, I will have the address of the OS code that should be executed when the page fault occurs, because 12 corresponds to page fault. So in every entry, I will have the address of the operating system code that should be executed when the corresponding exception happens. So what does the hardware do? when an exception happens, whether it's a trap or an interrupt, it will know the number of this exception. Moment it knows the number of this exception, the hardware will go and look into this table and find out which address of the OS code should start executing, and immediately that address it will load into the program counter. When it loads that address into the program counter, what happens? The next instruction to be executed would be that belonging to the operating system. By this, what happens? When there is an exceptional scenario, the transfer of control goes from the current process that is executing to a OS routine. The OS routine is basically called the exception service routine. Many books call it as interrupt service routine, but we will call, to maintain some consistency, you should call it as exception service routine. Are you getting this? So, to sum up, the transfer happens when there is an exception. The hardware will know its number. Either if it is an hardware exception, it is already in the hardware to recognize the circuit necessary to recognize the number of this exception, number of the trap which is happening inside the process. The hardware has that circuitry. If it is an external interrupt, then they use this advanced programmable interrupt controllers to basically get the number. Once an exception happens, the hardware knows the number, and then it comes to the exception descriptor table, and in this corresponding entry it goes there, it finds the address of the operating system code that should be executed to serve this exception scenario, and then it loads that address into the program counter, and essentially the exception service or the interrupt service happens. So this is how the transfer happens. Now, what next? Once this transfer happens, what would be the next step? In some scenarios, the program should be terminated. Let me tell some case. The program is terminated in the case of, say, divide by 0 or segmentation overflow. But in some cases, the program that caused the exception scenario should be resumed. What are those scenarios? For example, the page fault. In this case, the program has to be resumed back. There is a page fault that has happened. The operating system basically gets control and it needs to load the desired page into the memory and transfer control back to the program. There is no issue in these cases when the program needs to be terminated. So when there is a divide by 0, there is an exception service routine. Once the divide by 0 happens, there is an interrupt service routine which will start executing, an exception service routine that will start executing, and what that do, it will print on your console saying divide by 0 error, and it will terminate the program, and now completely the control will be with the operating system. The control will not be transferred back to the program. So that's very straightforward. But in the case of a page fault, what will happen? When a page fault happens, immediately the operating system will go look at the page table. It knows that there is a page fault. It goes to the corresponding secondary memory, gets the relevant page, loads it into the main memory, and again I should start from the instruction where it stopped. The instruction which caused the page fault should be re-executed. In some essence, the cases where you are going to terminate, it is just a transfer of control. I need not come back. But in the case where I need to resume, it is something like a function call. A program, a function A, say main calls A calls B, then after B finishes, the control comes back to A exactly at the point where B was, the transfer went to B. It should start immediately after the point where B was called. After A completes, again the control comes back to main, and it starts at the point where, immediately after the point where A was called. So this type of, the second type where the program needs to be resumed after an exception scenario happens, is similar to a function call. So what does the operating system do? In these cases, it basically treats like a function call. So how are function calls handled? They are basically handled using the stack. I have mentioned this in one of the earlier classes. How do we use stack for function calls? So when an exception scenario like this happens, the hardware recognizes, for example, it's a page fault, the hardware recognizes that this is exception number 12, and before it transfers control to the operating system, in the stack it will put the program counter value of the faulting program. On the stack. Basically it loads the program counter value which points to the instruction which actually caused the fault. So this program counter is the address of the instruction that actually caused the fault, and then it transfers control to the operating system. Now the operating system can basically handle the fault. In this case, it actually brings the necessary data or the instruction code from the secondary hard disk into the primary memory. After doing that, what it needs to do, it basically goes back to this stack and it finds out which was the instruction that caused the fault. Now it has solved the problem. It will start resuming from the same instruction so that the program goes into execution. Note that a page fault, though it is created by the program, is not actually an error. It's not an error in coding. It is just that I don't have enough memory to hold that program, so I am trying to do a transfer. While in the case where we are terminating a program, it is because of an error in the program. So there is a difference between these two traps. Trap number 1, which is because of an error in a program, say divide by 0 or trying to access something which I should not access, when compared with a program which is causing a page fault. So to sum up, what next? In case of termination, it's straightforward. In the case of resumption, after handling the exception, the program, the hardware actually uses the stack in which the address of the instruction that actually caused this particular interrupt, this trap or exception is loaded, and once this service is done, the page fault is handled, then immediately the control goes back to the program exactly to the instruction where this, which caused the page fault. So this is how the exception scenarios in CPUs are handled. So to sum up, in the last 15 lectures, we had gone through some of the very fundamental things about computer organization. I really can't comment on how much we have covered from your syllabus, but what I planned and could achieve is that all the fundamental understanding that are necessary, the real crux of the point that are necessary to understand the various concepts in computer architecture and organization, I have made my best attempt to cover this so that it would be useful to you. I hope that this series of 15 lectures help you in preparing for your semester exam. I'd like to conclude by just giving a brief sketch of what happened in these 15 lectures. We started off with transistors, and then we went to gates. We introduced the concept of what we call as the functionally complete set of gates, the NAND gate. Is there any circuit, any Boolean circuit could be recognized using these NAND gates. Then we covered a bit of representation, binary number representation, the 2's complement representation, the signed representation. Then we progressed to understand the stages in the execution of the instruction. We looked at the 5-stage execution. Then we went and introduced the basic pipelining, the 5-stage pipelining, and why pipelining is important, how does it improve the frequency. We also covered some hazards in the pipelining. We covered the control hazard and the data hazard. When we went to memory, we understood cache, some very important aspects of cache coherency, write back, write through caches. Then we covered the paging, the virtual memory concept, and we conclude with the interrupt and exception handling. So these are all the subjects that we have covered. I have circulated to the QEEE 5 tutorial sheets. I hope you got the 5 tutorial sheets. Please make a very sincere attempt to answer all those questions in those 5 tutorial sheets. If you answer those questions in the 5 tutorial sheets, then this course is complete. If you don't do those tutorials, whatever I have done in the last 15 lectures is utter waste from your perspective, and also from my perspective, because you cannot get a grip over the subject unless you make a sincere attempt to answer all the questions with full satisfaction to you and to the tutor that are given in the 5 tutorial sheets. So please make a very earnest attempt to understand and answer the questions in these 5 tutorial sheets. I also want to put something about IIT education here. We do not test you. Suppose we set a question paper for these 15 lectures, we do not test you on what we have taught in the class. It is never recall. It is not that you can look through this lecture and probably memorize this entire set of lectures and answer our questions. You do ask questions that will use the concepts that are taught in the class. That's a slight difference between what you, the slight different scenario in IIT education. So all the tutorial problems that we have listed uses the concept that we have covered in these 15 lectures. And so please do try and get those 5 tutorial sheets and solve those problems. If you have any issues, please contact your tutors. They are also welcome to contact me. I will try and explain as much as possible. Right? And thank you very much, and if there are some questions, I am open. Please raise your hand or come over chat if there are questions. Question: what is the difference between trap and interrupt? When did you join the class? Amrita TN. Can you get Amrita TN? When did this group join the class today? I think I have repeated the difference between interrupt and trap more than 10 times. Are you all awake? So, a trap is something, again I repeat, I don't mind repeating, but I think your attentivity should improve. The trap is something that is caused by the program. For example, divide by 0. It is an error when I write a program. Assume I am a program, I have done that wrong thing. If there is a segmentation overflow, that is, I have been allotted some memory by the operating system, I try to go and access something outside this memory. These are all mistakes caused by me in the sense the program. That exception is called a trap. What is an interrupt? An interrupt is a scenario that is caused external to the program. The program is not responsible for that exceptional scenario. For example, a program is running, I go and press Control C. This Control C is not an error caused by the program. It is an external interrupt that we have given, and something that is external to the program that has caused the termination of the program. So the exceptional scenarios can be classified into two. Scenario number 1, where something is wrong in the execution of the program, an error that is caused by the program itself. That exception I call it as trap. When a program is executing and I press Control C externally, that is external to the program, that is called as an interrupt. So this is the difference between an interrupt and a trap. What is the difference between software and hardware interrupts? Again, I have wrote it in the class. 4 times I have told, and I think what's happening. Okay, anyway, a hardware interrupt is an interrupt, or we call it as trap. Trap is a hardware exception that is detected by the hardware. Right? For example, divide by 0 or a page fault or a segmentation violation, all these are detected by the hardware itself without any need for any external programming. So these are called as hardware exceptions or hardware, these are called as traps. Now all the traps are basically recognized by the hardware. While in the case of external interrupts, you write a software, you program an advanced programmable interrupt controller to say this means this. So these interrupts are basically programmed by the software, and so the recognition of those interrupts, yes, this is caused because of a disk, that comes because of a software. That recognition comes because of a software, and so that is what we call as a software interrupt. So this interrupt is actually a misleading term, we should say exception. An hardware exception is one that is detected by the hardware. All the traps are detected by the hardware, while a software exception is one that is being recognized because a program was done to recognize it in that way. For example, a disk is assigned interrupt number 45 because a software, say the operating system, has used the APIC, an advanced program interrupt controller. It has gone and programmed that interrupt controller to say that if there is a disk interrupt, please give the number 40. So 40 or 45. So this is called a software exception, and all the interrupts that come from external sources, they are basically classified as software exceptions. So this is my answer. Are you able to follow? Thank you, sir. Yes, sir. Okay. Next. Okay. So if there are no more questions, thank you and all the best for your all the exams, specifically the computer organization exam. Thank you very much.